Now this is a quite good problem. So this says we have a horizontal rays parallel to the x-axis, and now it passes through this slab. This is a cylindrical in nature. Uniform horizontal beam light passes through quarter cylinder. This is half, 1/4 of the cylinder. Now a patch on the table for distance x from the cylinder is unilluminated. This means now there is no light in this region. So this region is illuminated. So no light in this region. So no light. If you are able to find why there is no light, you will basically answer this question. So find. So what is the first thing? Find why no light for distance x. So if you are able to find this one, you can do this problem. Now see, if you remember, we have also said for total internal reflection, for total internal reflection, so for total internal reflection what we have, so for total internal reflection we have theta is greater than theta c. Did you remember or not? Now let us say one mistake that you can do in this problem, you can assume this is a thin glass and then you can apply the formula mu2 by mu1 by r is equals to mu2 by v minus mu1 by u. But this is formula is not applicable in this case because this is not thin this time. This is a 5 centimeter. Radius is 5 centimeter and this glass is also 5 centimeter. So this is not a thin. So this case thin formula, this formula can't be used. Can't be used. Now if you know it cannot be used, then you know the answer. Now see what will happen. Any ray that is coming here, let me make the diagram again. So if I have something like this, so this is my cylinder and this is my principal axis. So let us rub this one. So this is my principal axis, and now let us consider two rays. First ray that is coming here and another ray that is coming very below, and one more ray that is coming here. Now you see what will happen for this ray. If I consider this ray goes here, and now this is your center, so I can always make the perpendicular, that is the normal from the center. So this is the normal. So this is the angle of incidence theta. Now if this ray, this angle theta becomes theta c, so let us say this becomes theta c, critical angle. So what will happen at this point of time? This will make 90 degree and this will go here. Are you getting or not? So this will become 90 degree and it will intersect here. Are you getting? Because this is a case of total internal reflection, so this angle is 90 degrees. So this line follow TIR. Are you getting? Let us call this point as what this write. They write this point. Let us write this point as a point A. This distance is point R. This distance is R. Are you getting? Now you see what will happen if you consider this ray. Now for this ray, if you consider theta, now this is the theta for this ray. And now let us find this theta and this theta, which is greater, either theta is greater or theta c is greater. So you will see this theta is greater than theta c. Are you getting? So this angle is greater than this angle. So in this case theta is greater than theta c. So let us call this a theta 1. So this theta 1 is greater than theta c. So this light will go basically total internal reflection. So for this light you will have total internal reflection. This will be reflected back this side. You can verify yourself this is theta 1 is greater than theta c. A special you can think if this point is here, then theta is 0 degree, and if this point is here, in this case theta is 90 degrees. So this falls here and normal is here. So you see from going from this side to this side theta is increasing. So this angle is always greater than this angle. Anyway, you can prove this one yourself also. Now this means this light will be reflected back by the same angle in this direction. Now let us consider this ray. If this ray falls here, now for this ray theta is less. So let us call for this ray theta is theta 2. Are you getting? So this ray will basically intersect somewhere away from, so let us say this intersects somewhere here. So you will have some light. So you see in this region you will have light. So this is the last light that will give you the rate. So this side you will have light. you will have no light in this region, no light in this region you will have. So this is no light. Even you will get light in this region because this ray is coming here. So this ray will give light in this region. So below the glass cylinder also you will have light. So in this region is light. So there is light because due to the reflected rays. So due to the reflected rays. Now in this region you have light due to refracted rays. So due to refracted rays. Now in this region no light. Are you getting? Because this is a situation when theta for these cases theta is greater than theta c. Now things are easy. Only I have to apply equations. Now see, this angle is given. This refractive index is given 2 root 3. Mu is 2 by root 3. So for this glass mu is 2 by root 3. I can apply. So the first ray, this ray will at this interface it will go parallel to the x-axis, no deviation because angle of incidence is 0 degree through the normal. Now here if I apply a Snell's law, so let us say if I apply a Snell's law at the curved surface, so I can write if I apply a Snell's law at curved surface, so mu is 2 by root 3 mu sine theta, theta is basically theta c, is equals to mu 2 is 1 sine r. So we have to calculate sine r. Sine r is 90 degree. So sine r is 90 degrees. So now this means sine theta c is equals to root 3 by 2. This means theta c is equals to 60 degree. So this is the angle of incidence. Now if I know this angle theta c basically, and I know this angle, are you getting? So this angle is same as this angle. So if I know this angle, let me make this triangle again. So this is O, this point is P, this point is A. So I can write this angle is 60 degree. Are you getting? If this angle is 60 degree, so this angle has to be 60 degree. So let us make this triangle again. So I will have a triangle something like this. Are you getting? So let us go fast. So this angle is basically 60 degree. This is O, this is P, this point is A, and this angle is 90 degree. You see here, this angle is 90 degree. And now this radius is also given to you. Radius is 5 centimeters. So you have somewhere something like this cylinder here. So this is the cylinder, and this length is also given to you. This length is 5 centimeter. Now in this triangle I can find sine 60, this angle is sine 60 degree, or I can write cos 60 because I know this length. This is also radius, so this is 5 centimeter. So I can write cos 60. Are you getting? So this is 5 centimeter. So I can write cos 60 is equals to cos 60 degree is equals to this length, that is 5, divided by hypotenuse. So let us say hypotenuse is 5 plus x. This length is x. So 5 plus x. So 5 plus x is equals to 10 centimeter. So x is equals to 5 centimeter. This means if a small patch of 5 centimeter is unilluminated. See, this is the part that is illuminated, and then there is a patch of 5 centimeter that is unilluminated, and then again you have illumination. So in this region you have illumination. In this region you have illumination. Are you getting? If you see from the top, so this is from the top view. So if you see this one from the top, so this is the top view. So this is unilluminated, no illumination, no light in this region. So you will have a circular patch basically, no light in this region.